So, welcome to Turn Up the Heat, OpenStack and Kubernetes. My name is Robert Starmer. I'm the CTO of Cumulus Technologies. We're a small boutique consultancy helping people develop and integrate cloud services into their business. My co-presenter, Michael Schulz, is with HPE, focused on cloud architecture and sort of helping to manage those sorts of systems and environments for their customers. And we're going to go through a couple different things. If I blanket, wait, that one. So we have just a couple top-level topics that we want to talk about. We're going to talk about containers and sort of the operations around containers, sort of why people are thinking about this technology space. We're going to talk a little bit about applications relative to that as well. And then we're going to look at infrastructure models, at least one specific infrastructure model that can be used to actually implement that functionality. And at the end, Michael's actually going to walk through Kubernetes at a slightly higher level, so to sort of better explain how Kubernetes is working, and then a demonstration of that running on top of the HP Helion OpenStack variant. Right? If you guys have questions, I love questions. Feel free to stop me. I will try to pay attention to what you guys are doing if there's a specific thing you want to dive into deeper. So first off, when people talk about containers, they're usually talking about containers as this is the latest and greatest thing. My development team is actually starting to use containers, and we really started wanting to deploy that. What are they really talking about? Well, we're really talking about operating system segregation of processes, and specifically we're talking about that relative to Linux environments and Linux systems, right? There are now resources to actually enable more and more of the Microsoft services space as well, so it's not all Linux all the time anymore, but really for the most part we're talking about at least the model that's presented by that Linux segregation. This is a little different than a hypervisor model, and these diagrams are, I think, fairly common now, where I have my hardware level, that's my x86 server, or maybe ARM server in some cases, a host operating system of some nature. Even if that host operating system and the container engine or the virtual machine hypervisor engine are bound together, there's this underlying software layer that all these services run on top of, right? So to me, serverless is a misnomer, but there's still going to be a server there. And then finally, we look at exactly what it is that I'm bundling together to actually implement and deploy, right? Am I talking about, in the container space, really the application and its binaries? Maybe it's a statically compiled application, so there are no additional binaries or libraries that are needed. It's just one application that runs. In the virtual machine space, usually there's a full operating system of some nature, even if it's a very lightweight operating system, and then there's an additional set of services and binaries and libraries that go along with that. And then, of course, there's the hardware model, which sits in the back, which I think we've all sort of experienced plenty of times over. The real key here is that when we're looking at containers, the reason that people keep talking about containers is that they're usually application developers, and they're saying, well, the application that I deploy, I can just give you this bundle. That's all you need. Turn that thing on for me, operate that. That's why I like containers from an operator's perspective, right, or from a developer's perspective. The whole stepping stone into DevOps actually is even easier if I'm thinking about things in terms of containers. Because with containers, it's actually easy to deploy multi-system, multi-container environments on my laptop. I don't know how many of you actually tried to deploy like a three-way active control plane, multi-compute node OpenStack environment on a laptop. Done it? You can kind of squeeze it in there usually with 16 gig of memory. I've done it with 8, but it's tricky. Deploying OpenStack Cola, even multi-way Cola against 3 VMs is actually easy to do because the individual containers, the applications, don't take up all the extra memory space, all the extra potential disk space of the actual virtual machine environments that would otherwise be required, right? So that alone sort of really shifts the scope in terms of the development aspect. So you can see the containers really make a whole lot of sense for developers. Operators usually are thinking about things from a completely different perspective. They're thinking about, how do I upgrade the infrastructure? How do I manage the resources that are going into supporting these capabilities, right? How do I add in the load balancing services and the storage mapping services and the sort of the underlying network resources? So we're thinking about this a little bit differently. And even at the container level, right? So I've talked to plenty of development teams that love containers because they say, again, it's very lightweight, very simple for me to deploy, not a problem. But then they have to start thinking about the fact that it's not just a single instance, right? It's not just that one container. It's also the
Come on, ham it up a little more.
it's not just that container, but it's also the underlying resources that have to be managed. So I've been talking about container operating environments. I've heard people talk about container management environments. These are the tools that take that individual container resource and make it clusterable. right? So now suddenly I can deal with the fact that I might have not just one compute entity where my containers run, like my laptop where I'm running Docker locally in a VM, which is the old way of doing it, right? It's not just that one instance. Now I have multiple. So when I asked for a container to be started, the nice thing about the environments is that I actually have a scheduler, and it says, well, I have multiple targets where I can actually deploy that container. I'll schedule it onto one. I have better resource allocation, right? The other half of that, though, is that there are then a bunch of other services that I might need or might want to have for those containers to actually scale. Things like load balancing. If I have multiple container hardware targets, whether they be virtual or physical underlying machines, I often also want my storage to be shared, because even though people talk about containers as these exclusively ephemeral sorts of resources, I start one up and it goes away as soon as I launch it. I was actually just talking to Devanandra about the fact that Google says that their mean time between, mean runtime for a container is 5 seconds. Right? So I'm turning in some models, not all models apply to this, but in some models I'm deploying containers rapidly. Right? If that's the mean, that means that the actual median is probably in the order of 1 second, right? And the average is then somewhere a little bit above that, right? But these are the sorts of environments that we're starting to talk about, where the scale of change of the application is much different than the actual underlying operating environment. If I had to deploy Kubernetes every time I wanted to get a container running, or even Docker Engine every time I wanted to run a container, that wouldn't work, right? So we still have long-term operations. We still have those infrastructure resources that have to exist and be managed. And that's where the container operating environments come in and map to sort of the next piece of the puzzle, which is starting to think about the operating system that lies underneath that, right? So if I think about the different types of operating environments that exist, and we could probably even sort of break this out into sort of the higher level container-focused resource models, and that would be something like Docker or Rocket with Kubernetes, maybe LXC eventually, I don't know. Canonical's announcement might mean that they're going to do something there, or the Docker or LXC models with the Mesos, DCOS kind of environments, or even Docker and Docker Swarm. These tools are taking that base Docker layered file system image type and then managing them onto multiple systems. All of these services also have an additional layer of resource management. They can all manage some form of load balancing against those containers. So if I want to deploy a web front end as containers and deploy, let's say, 100 web front end resources, I'm going to want to load balance them. I can do that in multiple ways, but one of the simplest is to let the container environment actually manage that load balancing resource. Again, stepping back and thinking about it from an operational perspective, how do I implement that? Well, I need to have a load balancer somewhere in the system. And that might be an IP tables load balancer. It might be, the folks at Avi were saying they have some very interesting technology for managing load balancing of resources. F5, yes, didn't mean to exclude anybody. The Avi guy just hit me up. But anyway, so, but anyway, so there are all these different resources, right? There are open source projects as well that can provide that functionality. And often those resources are already being mapped into, like Kubernetes leveraging the HA proxy model by default, basically IP tables manipulation as just a generic, we can give you some kind of load balancing. But then you want that next layer as well. So suddenly you have multiple layers of these different resources that need to be managed. They're not necessarily deployed by these services. These services are thinking about how, right? I need to have 100 web servers always running. I need to have 20 application containers running. And then my backend, I still need persistence somewhere in my system, right? So what's that going to look like? Well, it'd be nice if I could actually run those as VMs where I have a little bit more long-term stability expectations and maybe some different security and persistent storage model expectations, right? So all these resources need to map together. I did it again, hit the wrong button. And this really is sort of this whole systems lifecycle management. So I have application lifecycle management that's being handled by the Kubernetes or Docker Swarm or CoreOS or Rancher. I mean, again, there's a plethora of different tools there today. All of them have some value. All of them have different models for how they manage and interact with those resources. But we're looking at dealing with rolling upgrades of my application. Right? That's what the container operating environment potentially provides. What does the rolling upgrades of my underlying infrastructure? Right? What does the rolling upgrades of my Kubernetes environment? Anybody have any ideas? Thoughts? Would you like to have that? Right? Oh, yeah, that'd be great, right? So what handles that? What handles the scheduling? And this is actually, I still think, one of the stickier ones, because like I said, if I have 3 targets for where I can deploy a container, something has to make a decision. Well, how much resource do I have on those 3 targets? Where am I actually going to turn this particular container on? Right? Have I asked for 1,000 share of the CPU, or I have asked for 1,000th share of the CPU? Right? That might make a decision, change my decision-making process. There are schedulers. One of the nice things about the DCOS environment is that it uses the Mesos scheduler, which is a very smart scheduler in its own right. Right? But that only works against that container deployment service model. What if I also want to deploy those container engines as virtual machines? Then I suddenly drop into another layer of scheduling, which is most likely going to be the OpenStack layer of scheduling. Right? Or maybe if I'm using a public cloud, maybe somebody else's cloud scheduler, but it is still a scheduling resource. I need to schedule this somewhere. I sort of said this on the stage earlier today too. If you start thinking about that scheduling concept, right? If I'm scheduling a virtual machine into a public cloud or even a shared private cloud, right? Often the very first thing I do from a virtual machine operations perspective is run a little bit of a performance test. Hey, is that machine where I dropped this guy actually, does it have enough capacity, at least currently, to run the application that I want to run with the latency I expect? It's a big question, right? How do I do that with a container? I really can't. Right? I mean, I could build some process monitoring into my container, but that means that now my container, which was just this lightweight little process that's going to run, becomes that much more complicated. Right? So suddenly, resource management, the whole scheduling question, becomes a major piece of the puzzle of how these things are going to work and how they're going to operate. I'm going real fast. You're going to have lots of time for your demo. Another area is network service. Right? Again, this is another one of these resource domains that is really important when you think about the overall system scale. Right? And again, I sort of talked about this just briefly this morning. One of the biggest problems with networks is that if I have any kind of an underlay network, so if I've deployed on a public cloud or a private cloud and I'm using tunneling as a way to actually tie my different instances, my different virtual machines together, and then I deploy generic stock Docker on top, so Docker Swarm, or Kubernetes on top. In all of those cases, the default networking model is to deploy a tunneling technology for that particular deployment. Right? So suddenly I have a tunnel sitting on top of a tunnel. Now, most systems are built around a 1,500 byte MTU, and a tunnel has, I think, a 48 byte chunk, so I'm going to lose at least 100 bytes out of my entire MTU, the maximum transmission unit that I have on that network, just to tunneling. Plus, I have to encapsulate and de-encapsulate those tunneled components every step of the way too, which means that suddenly I have twice the encapsulation, twice the de-encapsulation that has to happen just to get from one container to another, or one container to the network service that lets me get out to the rest of the world. Right? So that's a lot of added overhead. So we'd like to integrate those pieces. Right? So scheduling, network, storage mapping, yet another space where, if I'm going to actually do persistence in containers, which I've had people be very adamant that it's very, very much a viable thing to do, and I've had also other people tell me that they would never, ever, ever deploy a persistent component in a container. Well, even if you don't intend to go into production with persistence, often the ability to emulate your entire environment on a laptop, again, that my container is running my application component is very important. Being able to do that then into a staging environment where, again, I might want to still keep that persistence layer as something that's containerized rather than deployed into a VM. Right? So managing all of those resources is another challenge in the entire environment. Right? So how do I deal with that? I have to deal with the underlying infrastructure. And to me, this is where the OpenStack layer really fits in. Right? Because with OpenStack, I already have a tool that was designed to look at helping to manage infrastructure-based storage, helping to manage infrastructure-based compute, whether that be bare metal or virtual machines, or in certain models, there's now the Higgins no, it's not Higgins anymore. Zune? Yeah, I don't even know if it's going anywhere. That came out of the Magnum domain. So Magnum was the container engine, or container operating environment, container management environment, whatever you want to call it, engine for managing groups of servers, basically groups of VMs by default, into a Kubernetes cluster or a Docker Swarm cluster or a CoreOS environment. Right? So managing the deployment of those resources. The idea with Higgins was that you could potentially eventually manage individual containers, much like you would with the Docker command line. Right? No, Zune. I have to keep remembering to change the name. But that's one part of it. But if I have this infrastructure manager that is at this point, I think, fairly well understood. I would say that as of really Kilo, it was actually really stable. It was quite a usable system. I have all the tools to help manage all these resources for my container environment. Right? I can establish and map distributed storage to any number of virtual machines, potentially even any number of physical machines being deployed and providing that infrastructure. I have the ability to map a network to that environment. And there's another project that tries to sort of marry these two environments called Courier, which basically provides a CNI, so it's I think it's CNI, maybe it might be the Docker lib network, but basically a network interface model that provides a connection into Neutron. So the Neutron network service in OpenStack can actually provide networks for the container environment. So I get rid of the double encapsulation. I may still be tunneling, I may still be using VXLAN as the technology for providing that back-end network, but I have one interface for actually doing that.
Across multiple platforms.
Across multiple platforms.
So OpenStack and whatever container stuff you got.
Right, because Courier is just the interface for basically connecting the network container in. Neutron is still running, and if I have VMs, I will deploy network to them as well. Right? And there's some work to actually map that through hardware into the VLAN space as well, so that the actual ironic environment could also tie into that exact same environment. Right? So a very powerful way of saying I can manage now my physical metal, I can manage my virtual machines as potentially even a separate resource pool to help with that scheduling interaction. And then a set of resources that are just for containers, map all those resources together and provide a very powerful environment for all of that. Right? So that's what the IaaS tools might be like. Right? So provide those as an underlay. Now, I think I have a bigger one of these. That's why I keep pushing that button. So when we actually think about the interactions of all these things, I guess the other networking operation that really is kind of interesting is load balancing as well, because the load balancing is a service function, gives us a way to create a load balancer and then associate it into that container operating environment. Right? So yet another one of the resources that I would otherwise have to operate independently, I can actually map into the system. I need one of those. I need to be able to control it. I need to be able to tell some endpoint how to communicate with it. A very powerful aspect. But how do I do that? How do I get OpenStack to help me map all those resources together? Well, that's where a templating engine comes in, or maybe a workflow engine, right? So there's both Heat and Mistral. I don't know if you guys have ever experienced Mistral. Basically, I would say it's a different version of Ansible, right? I mean, one way of thinking of it, because it's basically a task-oriented thing. Do this. If it passes, go ahead and do this. If it passes, go ahead and do this, right? So it's a very linear thinking sort of an approach to workflow, right? And then you have Heat, which actually also has embedded in it that same sort of hierarchical, well, this resource has to exist before I can actually build this resource, which has to exist before I can build this resource, but I describe it differently. With the Heat model, I describe a template. This is what I would like my environment to look like. I would like to have from 1 to n minions in my Kubernetes environment. I would like to have 3 controllers in my Kubernetes environment. I'd like to have load balancing as a service mapped into my environment. I need this distributed manila storage layer that's distributed across all my instances as well. So now I have persistent storage if I want to go that route. I have networking through Courier to enable the actual networking interface for those containers that are about to be deployed. And I have load balancing, and then, of course, the final straw is to spin up the virtual machines and actually get my instances running. Right? But even this is not quite enough. I can actually get my environment, the model for the infrastructure for my environment deployed. That's really what Heat gives me, a way of talking to all the different OpenStack services. But the OpenStack services do not deal with turning on Kubernetes, turning on Docker Swarm environment. Right? So in order to do that, well, actually, just talk a little bit more about Heat. So again, template-based automation. And the resources, like I said, they're the OpenStack resources. So Nova, Cinder, Swift, right? My Neutron, my load balancing. I could do firewall services and VPN services from the network space as well. All of these are available. I can now provide that infrastructure as a usually mostly virtualized, but also the ironic calls are also available through this same interface. So I can actually define these templates that build out these resource environments. Right? I actually haven't checked if there are Courier specific calls, but I believe that there should. If there aren't, there will be. Right? Because Heat tries to support all of the different services. And what these components are, these are known as the resource domains. Right? So underneath all of this, for example, there's an OS Nova server component, which is what describes a server aspect of Nova, right? So if I want to boot a server or shut down a server or add an interface to a server, I would be using the resources underneath that particular resource type, right? The templates are good for driving lots of things, and in fact, they are being used by the two other projects that talk a lot about supporting the deployment of containers in OpenStack, and that is the Murano project, which provides basically a catalog-based approach. Hey, I would like one of those things. Can you give me a Kubernetes environment, please? You know, click a button, and it will take care of the automation. It does that through heat, right? The other one is the Magnum project, which is a little bit more of an administrative view of managing lots of OpenStack, or lots of container operating environments on top of OpenStack environment, right? And they can be multiple types. The heat templates are not only Kubernetes or only Docker. There are multiple options for how you would actually go about deploying that. And of course, there's the option of not using these, but just using the heat templates themselves directly. Right? Most end users are given access to heat. It's a very powerful tool for them to build their own application environments, and all that really the Kubernetes sort of service or the Docker sort of service is another one of those environments. Right? Now that's not enough though, because what that's doing is it's giving you the infrastructure. I still need something that's going to actually turn on Docker or turn on Kubernetes. And there are a couple of different approaches. One is I could build out a static image. Right, a default image that has all the right components, just needs a little bit more configuration passed into it. Yes, question?
We use Cloud Init, right?
Yes.
So why do you need Chef expansive public? You can instantiate services with Cloud Init.
So here's my view.
Or if you want to do
I was about to say Cloud Init would be another way of approaching that, especially if you've sort of pre-established that you have all the right resources locally. The reason that I like these tools in general is that, and having actually just done this again recently, I had somebody who said, look, I just wrote a quick bash script to stand up a single node OpenStack with Cola. There's 5 commands that you can run that all the defaults will be set up appropriately and you can have an environment. And then you start thinking, oh, well, you know, that script works really great for me, but there's a slight difference because the network interfaces that I see are different than the network interfaces you see, which means that the script only works for me unless I go in and hack it. Right?
You could build libraries that you source dynamically through Cloud. I mean, it's just where you get.
So how many Cloud Init and Cloud Config developers do you know?
The way that everyone's doing, if you look at Kubernetes, the core REST example, deploying Kubernetes on AWS, it's all Cloud.
Okay.
I mean, so there's enough canonical examples of instantiating services, not necessarily operational as examples.
That's the big difference.
You
Yeah.
can get a more declarative, immutable approach to instantiating services.
Right, so I think there's a big difference in terms of, I would like to instantiate this because I need to try it, I need to understand it, I need to start developing against it, versus I need to operate it. I need to have some kind of way of determining consistency. And that's where these tools come in, right? I mean, the tools, while we talk about them in terms of automation, they are really compliance tools, right? This is the state that I expect it to have, and it should look like this. So can you please make sure it looks like this, right? I don't disagree with you, by the way. I'm not saying that Cloud Init is a bad approach. I'm just saying that there's a reason that people have gone this route for actually doing some of this work as well.
Yeah, it's also the long term, you know, something like that, if you've got Ansible or you've got Chef, if it's a long-term living thing, if you need to change it, you can.
Yeah, like
It's
my
the entire-
wrote like immutable of the future, so it's more it's virtual, so it's disposable. So you create a stack, you're not really worried about configuration drift. You just build it, throw it away, blue green it, turn it over, you know, you
It's
instantiate
pets
another one.
versus cattle.
Yes.
I mean, so it's
You know, if
this
you've
is the
got-
intermediate step, right? Of like, all right,
This basically works for all.
yeah. What's it good for bare metal? But anyway.
Well, it's good for bare metal. So look, the question is, do you treat VMs as something different than bare metal, or do you treat the entire environment, regardless of how you've built it, the same way? Right? How do you build your containers? Do you write specific scripts just to build the containers that you deploy, or do you say, well, container might be the right solution, but if I suddenly find that I want to deploy it on a VM, now I have to go and rebuild my deployment automation just to actually do it that way, right? Well, if I use a tool like an Ansible model to actually build something, again, you could use Cloud Init, you can actually build the models there as well. There are lots of approaches. My point was simply that this is one of the main ways that I've seen people do this, and in my own practice, this is what I tend to do as well, because I have written plenty of bash scripts to get something started, and the very next thing I do is say, Great. Now I need to tweak it. Now I need to update it. I need to change how this works. I need to make it more flexible. And I have written a lot of crazy bash that is just unmaintainable. And this stuff becomes unmaintainable as well, right? I mean, Puppet for OpenStack, right?
Cloud init is the machine, virtual machine kind of analog. Docker file, you're building with a Docker file. Ansible
Well,
is kind of the,
look, Cloud Init to me is a very powerful way of providing a unified model for the equivalent of Kickstart or Bootstrap of any kind of hardware resource. I use Cloud Init against bare metal machines, right? As long as you can get the process running on your target environment, you have a way of passing it the next level of configuration information. And that could be the complete system, like you're saying. I don't disagree with that. But there's enough complexity in that I think sometimes this model, which is also a shareable resource, is just a different approach to doing that, right?
another DSL.
It's another DSL.